All right, so one of the first steps obviously is getting to Cerakote my SLS parts is I'm going to need a curing oven as part of the process that can get up to about 200 degrees Fahrenheit. So I happen to have this cabinet. I installed these cabinets in my garage about 9 years ago, and I've never used this one, so it just became a convenient vessel for an oven. I saw a lot of YouTube videos online that use similar metal, wood cabinets, and so forth. So the first step then is to line the interior of this with the thermoboard material and then a reflective aluminum tape. So you want to use this material, thermoboard. You don't want to use the EPS foam. It can't handle, it can only get up to about 180 before it starts to melt, which is not good because that's about the temperature you cure SLS nylon parts. So you want to use this type of board. Got this at Home Depot. It's a more of a foam, polyasol foam, polyurethane foam that can withstand temperatures closer to 250, closer to 300 potentially, but we don't need to get that high for this particular oven for SLS parts. So got all this lined up and sealed up, and so the plan here is I'm going to use a ceramic, it's a curved heater I found online that'll fit in the bottom and it'll radiate up. I will cut a hole in the side over here. I have a 12 volt, about a 4-inch DC fan that I'll mount on the side here, because I think you do everything I read. You want some sort of airflow inside the oven. I know a lot of people do it without it, but I think it's just smart to have some flow. So I actually have this threaded rod as well. I'm going to drill through the side of the cabinet and run this through, and then this will be, I'll just cap those ends, and then this will be what I hang my parts on. So this will hang up in here, and I think that should do it. I'm going to, I know a lot of people actually use a heat gun to heat the interior of these. They can get up pretty hot, but they're noisy for one, and they're bulky and sit on the outside. I am going to test this with my small heat gun just to see how well it holds the temperature and what it gets up to. I will be using a PID controller to control the heat on this, and that's very important. You want a very constant sort of heat. You don't want fluctuations here. So we'll have the PID controller. When I get to that point, we'll show you how I wire all that up. But for right now, we're just going to kind of put a heat gun in there and just see how well it holds and what temperature it gets up. It's a 300 watt heat gun, so it'll be interesting just to see what that does. I know the larger, the 1,000 watt heat guns, they can heat this up to 1,200 degrees, and we don't need that. So this is my first process in a Cerakote drying oven for SLS parts. All right, so we're going to do a test, see how quickly this heats up. This is just a 300 watt. Actually, this is a 300 watt heat gun, and I'm interested to really see how well this heats up. I actually, I've got the thermometer here on the side. It's it actually was around 72. I actually turned it on just for a little bit, and I didn't have my camera and everything ready, and it heated up pretty quickly to 75. So you can see about the ambient temperature. Here we are in Louisville, Kentucky. It's December 26th, and it's literally like 65 degrees outside, or rain. So that's where we're at. So let's go ahead and turn this on. So it's already down to about 72 there, and we're gonna go ahead and turn this on. It won't be completely sealed, but it'll be close enough. And so we're just gonna let this run, and you can see it's already cranking up pretty good. So that's up to almost 90 in just literally like 20 seconds. And for SLS, we're going to need to, I believe I read online, Cerakote says for SLS nylon, it's been tested around being about 180. So, I mean, the good thing about the heat gun here, of course, I hope some of the plastic doesn't melt, actually, think about it. that could be my bigger problem. Just a 300 watt, you can see I'm already up 120. That's pretty impressive inside. So we'll see how we'll. I think I'm going to shut her down probably here in about. I got some plastic in there. I got to just worry about that, I think. But yeah, it's nice and toasty. What the heck? Let's just push the limit a little bit. So, just to kind of give you an idea, I mean, like I said, this is just a 300 watt. You know, if I could put this heat gun in there without it parts melting on it, the plastics and stuff, that would probably be something I would consider, because it's really not that noisy in itself. And I would just hook that to the PID controller. But I think easily, I did a calculation actually. There's a place online you put the size of your the box in there, and it says I only needed about a 400 watt to go from a 140 degree difference change. So we're already up to 153. So this obviously holds it pretty good. Let's turn the heat gun off and then just close it up, and we'll see how it holds that as well. So I took out the heat gun now out of there, and so it's not 100% insulated. Obviously, we got some leak, and we probably can go around this and maybe tape up some more of this in the corners and stuff. I noticed that I couldn't get in there 100%, so we'll go ahead and tape some of this up. We'll probably tape all the way around, just kind of seal it, and we'll see how. But it's dropping fairly quickly, so let's seal it up. And also too, I think I've got some gaps here at the top of the door. Well, no, I think I did seal it pretty good up there. So we'll do some investigating, see if we're potentially we have heat loss spots, and then we'll get that retry it. All right, so we've got the fan here. This is the 80 millimeter by 80 millimeter fan. So what I'll do is I'll create a PA12 part here. This part here, this will mount to the outside of the cabinet, and then this will be a little piece of aluminum ducting here. So there'll be an inset on in here. It'll help hold it. So it'll go up to the fan, and then that ducting there that I just got rid of go through the cabinet, through the insulation, and then into this baffle here. So you can see the baffle. What I'm going to do is, when I designed this originally, I thought I had enough angle it up, but I'm actually just going to mount it at an angle here, and then it'll go to the back, angle to the back, and up on the cabinet back face. And that will, based on some AI help, it told me how much coverage I should have, an angle, and that is my concept. So I'll print an FDM one real quick and put it in the oven and just do a low temperature test just to see how well it works, and then we'll go from there. But this is kind of the fan concept and how it's going to mount. All right, so here are the parts, the fan housing parts. This is a quick printed in with an FDM printer. They'll be printed in the SLS PA12 material. So this here is the outside part where the fan will mount to, and then this here will be the baffle piece. So both of those, we'll put that ducting in between those through the walls and attach that. And then we have our ceramic heater here. This is the 1000 watt. It's from More Electric, I believe, is the company where I purchased it from. And that has a clip on the bottom. And so then I had the guys fab up this reflector plate. So this ceramic heater will sit on top of that, and then that will sit on the bottom floor. And then you can see all that here in the cabinet mounted there. And then over here in the you can see on the right, I have the spot marked where I'm going to drill out the hole for the fan. And then lastly, this is the PID controller kit that I bought. It's Amazon. It's a pretty good kit. It comes with the SSR and the heat sink, as well as the thermocouple. It's a K-type thermocouple, and then the pit itself. So we'll get all that hooked up in the case, and we'll just do a test run just to make sure everything looks like it works out as far as the design concept. So this is the oven all hooked up. We've got the convection fan going and the pit controller. I got it set for 120, and it only took about 3 minutes to get up to the 109. And at this point, the ceramic, the SSR, starts fluctuating and turning on and off the ceramic heater. And so now it's going to start to climb closer to 120, and it takes about, less than 3, and then it takes about another 5 minutes actually to stabilize to get to the 120. If the fan was not running, I did it, it heats up pretty quickly, and it overshoots by about 10 degrees. So with the convection fan blowing, you actually get very stabilized temperature, and it gets a very smooth transition. So I was pretty happy with how it stabilized, and it stays within ±1, frankly, of the set temperature. So now that I've established that I've got a good working concept here, I'm going to go ahead and build the pit enclosure box, and just I'll show you in the next video just all the wiring and the final probably oven setup with the pit, since this is long enough video just to kind of show you this working concept. So come back and we'll show you the whole pit setup.